Right, good day, Matrix. Welcome to Matric Question Monday, episode 3. I'm glad you've joined me. If this is the first time joining, every Monday at 2 o'clock, about 2 o'clock, I will post a video where I look at some Matric questions from past papers. In episode 1 and 2, which you can also find in the same playlist that this one is, on my channel, I've looked at question 1, which is algebra, from the Gauteng Department of Education's preparatory examination, September 2015. And today we are going to look at question 2, which is now patterns, numbers, sequences, and series. Number patterns or sequences and series chapter. This is arithmetic and geometric sequences and series. So this is exclusively Matric work. It's not grade 11. And also would like to just ask you, if you do come across, if you are working on your own time through past papers and you do come across very intriguing or very difficult or very challenging or very cool questions, please comment them below or send a link to the question in the comments below this video, or any Matric Question Monday video, and I'll have a look at some of the funny questions that you also come across. Right, so let's look at question 2. It says the first two terms of an arithmetic series A is given, and an infinite geometric series B are the same. So it's both minus 2 and x. It's an arithmetic series that starts minus 2x and then something else. Geometric series also minus 2 and x and then something else. And they've just numbered them A and B, and they also give the 2 here. Then they say 2.1, write down in terms of x the third term of the geometric series B. So I want the third term. Now there's one of two options you can do here. You can use this formula, that the fact that the constant ratio for geometric series is equal to term 2 divided by term 1, but it's also equal to term 3 divided by term 2, and it's actually also equal to any term and its previous term divided by one another. But I've got 1, 2, and 3 which I want to work out. And then from this I can just substitute. My second term is x, my first term is minus 2, my third term I want to work out, my second term is x, and then from there multiply with x both sides to get rid of this. Then I've got x squared over minus 2 is t3, or I can write this also as minus, let me write it the other way around, the t3 equals, you can also write this as minus a half x squared. It's the same thing, this and this is just two different formats. This just looks better to me, but I'm sure that's fine also. Okay, another method you can use for this is calculate the r value from x divided by minus 2, and then you have the a, which is minus 2, the r, which you can calculate by taking this divided by this, and if you want the third term, you can just substitute in the general formula a r to the power of n minus 1. The r you have, the n you have. If you want to calculate the third term, you can substitute 3 there, and then you have everything in this formula, and you can just work out the third term. Right, so that's just another method you can also use. Okay, so for 2.1.2, they say the third term of the arithmetic series A. Now the third term, you can, again, we can use in an arithmetic series, I have a constant difference, which is term 2 subtracted, and subtract from that term 1, which is also the same as term 3 subtracted term 2, which is also the same as term 4 divided by, subtract term 3, or term 5 subtract term 4, etc. So you can again use this method that I used, just with the appropriate formula for the appropriate type of pattern, or you can work out D and then use the T n equals a plus n minus 1d formula to work out the third term. Right, so you also have the two options here. I'm going to do this. So I've got the second term is x minus the first term there is minus 2. The third term I want to work out minus the second term is x. So this is x plus 2 is equal to term 3 minus x. I'm going to take the x over. I've got 2x plus 2 is my third term. And just maybe for the sake of not having to, if I need this later on again, not having to search through this again, I'm just going to put this third term of the geometric pattern is minus a half x squared. And the third term of the arithmetic pattern is 2x plus 2. And I'm just going to write them there so that I don't have to constantly search through my work. But also now I'm going to take my work off because I want to have space for the next questions. Okay, so question 2.2 now says, if the sum of the first three terms in the arithmetic series A, the sum of the first three terms, which is basically this what's standing here, sum is most plus, and the first three terms, so it's exactly that. If the sum of the first three terms of the arithmetic series A is equal to the third term of the geometric series. So if this, B, then calculate the value of x. So I must just now calculate the value of x. I've got an equation and I'm going to go with that. This is quadratic, so I'm going to take over everything to one side. I bring this over. Minus 2 plus 2 actually cancels. And x plus 2x is plus 3x. And then I don't have anything here because I took this over. Then I can factorize. I take an x out as a common factor. And I've got x is equal to 0, or x is equal to half x is equal to 3, which means x is equal to minus 3. I'm lying. X is equal to times 2 minus 12. Nope. I'm jumping ahead of myself. Half x is equal to minus 3, and then if I multiply by 2 both sides, then I get x is minus 6. Great. Okay. But now with the number patterns, always just think logically about this also, especially when you get things like 0 or 1. Just have a look at the effect that it does, what it does there. So if I have x is 0, then if I make this x 0, this term becomes 0. If I make x 0 here, this term becomes 2. So then this term is minus 2, 0, 2, which means the arithmetic pattern is counted in 2s. Minus 2, 0, 2, 4, 6, 8. That's fine. That's perfectly fine and acceptable. But for this pattern, if I make x 0, this term becomes 0. This term becomes 0. And then I have minus 2, 0, 0. And if I have 0 there, it means I multiply it with a 0. I multiply it with a 0. And this pattern will be minus 2, 0, 0, 0, 0, 0. My constant ratio is a 0. And also if you think about, which is not a likely pattern actually. It's not impossible, but can you see that if my x is 0, my pattern looks like this? And I question this a little bit. And if you go and play with this, you can see term 2 divided by term 1, that's fine. But term 3 divided by term 2, whoop, that I cannot do in maths. So it doesn't just look funny. This is actually going to give me some mathematical problems if I make x 0. So I cannot do that. Especially with the geometric series, it gives me some problems. So I'm going to take out this solution and then you can, same way that I just had a look at what the x0 does there, you can have a look at what the x minus 6 does to the two patterns. X equals minus 6 does, and then just figure out, is this a plausible answer? But it is. So that's fine. Okay, and then in question 2.3, they say if x is minus 6, does the geometric series B converge? If x is minus 6, does the geometric series B converge? Show calculations to support your answer. That's the final question for today. If x is minus 6, the geometric series minus 2 plus x plus minus a half x squared looks like this. Minus 2, minus 6, and this minus 6 squared is 36 times minus a half is minus 18. You're more than welcome to work that out with your calculator too. And then this R value, it looks like this, which means my R value is minus 6 over minus 2, term 2 divided by term 1, which is 3, or term 3 divided by term 2 minus 18 divided by minus 6, which is 3. And for convergent series, I need my R to lie between minus 1 and 1 if it is convergent. So my R is 3, it doesn't lie in that spectrum, therefore this is not a convergent series. Okay. Right, so please, if you come across awesome Matric questions that you want me to have a look at in Matric question Mondays, please let me know in the comments below. I'm looking forward to having you all back next Monday, and next Monday we are looking at question 3 of this paper, which is still questions about this geometric and arithmetic number patterns chapter. It's now looking at the sigma notation and questions to do with that. So looking forward to that. See you next week. Bye.